Hello everyone. Let us now talk about today's Leetcode POTD. Leetcode 2563. Count the number of fair pairs. So in the description it is given that we need to find a pair and it should be 0, and there is a condition that 0 is less than or is equal to I is less than j less than n. So we are given with an array nums of size n, and the second condition is nums of I plus nums of j is less than or is equal to upper, and lower is less than or is equal to nums of I plus nums of j is less than or is equal to upper. That means first if you look at this thing and these two conditions, and if you take an example 0 1 7 4 4 5, if you sort the array we will get 1 comma 0 0 comma 1 comma 4 comma 4 5 comma 7. That means think about it, when we are at 0 and the lowest sum we can get is 3 and the highest sum we can get is 6, so we need to know what is the lowest number, that is 3 minus 0, and the highest number which we can add to this number is 6 minus 0. This is nums of I and this is lower and this is upper. So for 0 we need to know what is the lowest number, that is 3, and here highest number is 6. So we need to know how many elements are coming in this range. That means 1 is not in the range as 1 is less than 3. Now 4 is greater than 3 and less than 6, so here, and another 4, it is also valid, and f5 is greater than 3 and less than 6, so it is also valid. So we have 3 elements which are valid. So now the count becomes 3. Initially the count will be 0, we will be counting the number of fair pairs, so the count will become 3. Now let us move to the next index. Now we have 1, but when we are at 1 we need to consider this subarray after that index. That means we need not to go to the previous indices which will increase our time. That's why sorting this array will help us. You might be thinking that what about this condition, I is less than j and I nums of I plus nums of j is less than or is equal to upper and greater than or is equal to lower, but we are satisfying this condition. Nums of I plus nums of j is coming under this range, coming under the lower and upper range. But for I is less than j, imagine if 1 is placed here and 4 is here, 1 plus 4, here the indices are 0 1 2 3 4 5. 1 is less than 3, and here if I say I is here and j is here, 1 plus 4 will come in this range. But if I sort in a descending order, it will become 5 and 1. Now I and j are reversed, but will it change the sum? No. That's why we need not to consider this. We have when we are sorted array. So that's why there is a need to sort this array, and here we are at the index 1 and the element is 1. So what is the least number which we need to add to this one so that we get to this range? That means we get the lower number, that is 3 minus 1, that is 2. And what is the largest number or the greatest number which we need to add to this one to get in this range? That means in the range of lower and upper, that is 6 minus 1, that is 5. So again we need to consider another subarray so that we get a fair pair. That means adding 2, 3, 4, 5, adding these elements to our current element 1 will make a fair pair. That means we need to consider the next element. So this is the subarray. 4 is valid as it comes under our range. 4 and then again 4 and then 5, but 7 is not valid. 7 plus 1 is 8, which will go out of the required range. So 4 comma 4 comma 4, the size here is 3. Now 3 plus 3, 6. Again when we come to 4, we need to check what is the lowest number which we can add to 4 to get in this range. 3 minus 4, we are doing the same thing again and again. 3 minus 4, it is minus 1, and 6 minus 4. In the next subarray we doesn't have any element which is equal to or greater than the lowest number. So here we cannot find any pair, and then same element we cannot find any fair pair, and then we got 5 here. 3 minus 5 is equal to minus 2, and 6 minus 5 is equal to minus 1. We doesn't have any element after this which is minus 1 and minus 2. So this is the main advantage of sorting this array. But when we have like this, we need to check again and again, and we need to check again and again this example when we didn't sort the array. So when we have 4, we need to check is there any 1 or is there any 0 or is there anything which can add to that element and will come in this range. So we need to do two things here. First, sort the given array, and the second thing, iterate the array from 0 to less than n, and then find the lowest number. Here as we found lowest number and highest number, and then we need to do a binary search algorithm to check the lowest number and the highest number in the subarray. After, if the present index is I, we need to check the lowest number and the highest number in the range I plus 1 to n. If we got a lowest number here and highest number here, so if the current element is 0 and we got lowest as 3 and highest as 6, so if we found those elements, what is the size of this array? If we have a size, if it is at j and it is at k, we need to do k minus j plus 1. So by doing this, if we found like this 0 1 2 3 4 5, we found 4 comma 4 comma 5, this is the range. Now we have 4 minus 2 plus 1, this is the size of the subarray. So we need to do k minus j plus 1. So to find the lowest bound and the highest bound, we have a predefined function in C++, that is lower bound and higher bound. So as I mentioned, if we are at index I, we need to do the binary search or find the lowest bound or the highest bound from when I say nums dot begin plus I, as we are at this element, that means we are beginning this nums and getting to this index I, and the array which we are searching is nums dot begin plus I plus 1, nums dot begin plus I plus 1, and we need to search from that index to the end, and then we need to check for lowest number from the subarray starting from the next index of the present index to the end, and we need to check for the lowest number, and we need to minus nums dot begin. This will be the index, of the lowest bound, and for the highest bound it is same as the lowest bound, begin plus I plus 1 comma nums dot end comma highest number minus nums dot begin. So as I said before, lowest number and highest number is equal to lower. As I mentioned before, we are eliminating or subtracting nums of I here. Lower minus nums of I, and for highest bound or highest number, upper minus nums of I, and we need to increment the count by upper bound minus lower bound. So after iterating this, we return our count. This is how you approach this problem. Thank you.